In this video, we'll write the net ionic equation for CaCl2 plus AgNO3. This is calcium chloride, and this is silver nitrate. The first thing we need to do with net ionic equations is balance the molecular equation. It looks like if I put a 2 here and a 2 here, that this equation would be balanced. So that's our molecular equation. Now we need to write the state for each substance. Calcium chloride. Chloride compounds are very soluble, and they'll dissolve and split apart into their ions. Put an AQ after that for aqueous, dissolved in water. Silver nitrate. Nitrate's also very soluble. So we'll say that's aqueous. And then here's another nitrate, so that'll be dissolved in water. But silver chloride, we should probably look that up. Silver compounds are a little bit odd in terms of solubility. So let's look that up on a solubility table here. We can find silver right here, and we're looking for the chloride. There's that chloride Cl minus. So we go down and over, and we see that I there. That I means that silver chloride's insoluble. It won't dissolve. Because it doesn't dissolve, when we react these two and we have silver chloride formed, it falls to the bottom as a precipitate. So we just say that that is a solid at the bottom of the test tube. So we have our states. Now we can split the strong electrolytes apart into their ions, and this will give us the complete ionic equation. So strong electrolytes, they're the ones that will dissolve and dissociate these ionic compounds here. So we need to know the charge to do that. On the periodic table, calcium's in group 2. It has a 2+ ionic charge. Chlorine has a 1- charge. So we have Ca 2+ plus that chloride ion, Cl-. Subscript, that means we have 2 of those. Then silver, it's a little bit odd. Silver is a transition metal, but it's always 1+. The nitrate ion is always 1-, this NO3. Good one to remember. So we have 2 silver ions plus 2 nitrate ions. And those are the reactants in our net ionic equation for CaCl2 plus AgNO3. For the products, we said this is 2+ and the nitrate is negative. We have Ca 2+ plus the nitrate ion, NO3-, but we have 2 of those. And then for the solids here, when we do net ionic equations, we don't split apart solids. They're not split apart in the test tube or the beaker. They're just sitting at the bottom as a solid. So we're just going to write 2 AgCl. That'll stay together as a solid. And this is the complete ionic equation. Now what we can do is cross out the spectator ions. They're on both sides of this complete ionic equation. So essentially they haven't changed. So on the reactant side here, we have Ca2+. We have it on the product side as well. So we can just cross that out. We also have 2 nitrate ions and then 2 nitrate ions here. Cross them out. Everything else is unique, and that'll give us our net ionic equation. So we have 2 chloride ions, 2 silver ions, and then we end up with this solid AgCl. Let me clean this up and write the states in, and then we'll have a nice tidy net ionic equation. So this is the net ionic equation for CaCl2 plus AgNO3. You'll notice that we have a 2 in front of everything. Often teachers like you to have it at the lowest number, the lowest ratio. So we could just delete the 2's like that, and then there would just be a 1 there, although we don't write it. And this would probably be a more accurate, and this is probably a better way to write the net ionic equation. Note too that sometimes people write the positive 1 first. It really doesn't matter. At any rate, this is the net ionic equation for calcium chloride plus silver nitrate, and this is Dr. B. Thanks for watching.